Okay, so last time we were talking about how to set up circuits like this in multisim, which I think is very useful. Um, and again, you don't really know at this, really need to know at this point the theory behind op amps. So if you're not really familiar with it, like I said before, it's not an issue in this class because this is not a circuits class. But in any case, I'm interested in you knowing how to find the different components, how to set them up, how to use the instruments. That's the idea behind this section in using multisim. So in any case, I wanted to show you a few of the features while we work on this kind of circuits. And again, if you remember, this is an amplifier. It's an inverting amplifier because of the negative sign. It automatically implements in the equation. But it is an amplifier that you can adjust by selecting the resistors. So by selecting the ratio of resistors, you can make the gain of the amplifier to be a certain number. So what I want to do is to go back to our multisim and this time, however, I want to use an integrated circuit to set up the, the previous open that we had. Remember last time we used an op amp, but we used a virtual op amp. And nothing wrong with using a virtual op amp, but the actual, when you use the virtual op amp, it's not like the real device, okay? Yeah, that's why it's called virtual, because all you need here is the three terminals, two for the input, one for the output. But in the real world, op amps are what is called active devices, meaning that active devices require power to be able to be used, to be owned. They require some power before they can actually be used in circuits. So what I wanted to show you is more of the real world case where we use integrated circuits that include the requirement that the device has to be powered. Okay, so let me get rid of this one here and then use an actual op amp. And I'm gonna look for, there's a lot of op amps here, as you can see. I mean, a lot of them, a lot of models um, for different purposes, different reasons, different features, and so forth. But one of the most commonly used, most popular ones is this LM741. Okay, and that's probably the one you're going to be using in your labs and everything. So this LM741, I'm going to open it up. As you can see, it's an operational amplifier. And I'm going to set it on my protoboard area here, breadboard area here. And as you can see now, it has more connections, right? And just to, again, you don't have to do this, but I'm going to flip it just so we can have the same kind of format that we had in the slides where we had the positive terminal grounded, right? So you can see the same flow, in other words, but you don't have to flip it. But as you can see here, again, we have two inputs and one output, like we already know. But there's some other pins. And if you double click on this, you'll see that you have different pins, right? You have an in, two ins, one for positive, one for the negative. You have an output, obviously. And then here you have a VS plus and a VS minus. And these are labeled power, okay? So VS minus is going to be connected to the negative supply, and the VS plus is going to be connected to the positive supply. This type of devices require two power supplies, one negative and one positive. Okay, and that's the most realistic application of op amps. There's a couple of the inputs here that we're not using on those two pins. Those are usually used for other purposes and sometimes to connect other sections to other circuits. but for the purposes of this example here, we're not going to use those two those two inputs here. So, but we're going to use the other 5. Okay, so again, 2 are for input, 1 is for output, and 2 are for the power. 1 is negative and 1 is positive. So let me keep this a little bigger here. And so now I'm going to, again, set up the circuit that I had set up before with the virtual open, but this time I'm using an integrated circuit, right? And this is an actual integrated circuit. If you do a little search, you can look at some of the device characteristics, some of the specs for this specific device, and you'll see that it's very realistic to the one we're using here. And that's the advantage of using integrated circuits here, because it will give you a more realistic simulation, okay? But in any case, let's bring the portions that we need. We need a DC power supply. Okay, and I'm going to set it aside. I need a ground. I need a ground for my supply. I need a ground for my positive terminal, input terminal, which I'm grounding for this particular case. And I'm already, if you notice, but before I do that, let me get the we also need resistors. Well, we also need, remember I told you we need the supplies to power on the device itself, right? So I'm gonna set those up, and I'm gonna put one here and another one here. I'm gonna hook that up in a minute. This particular LM741, I think you can have power up to plus or minus 22 volts if you look in the data specs. But I'm going to use the 12 volt supplies. That means that the output cannot be larger than 12 volts at any point. Okay, that's the maximum that I can get. So that's okay for the purposes of this example. So I'm going to set up, I need a couple other grounds. I'm just going to set up on the side, and then I'm gonna hook them up in a minute. All right. I also need a couple of resistors, right? One for the input, one for the output. So I'm going to get cancel that, close that. So I'm going to need a couple of resistors. Let me just choose a 2K. I'm going to connect that to my input here. And I'm going to select, I'm going to use another one here, but in the feedback path, I'm going to make that a 10. And so I'm going to change the value to 10K. And that's okay. And I think I got everything I need to start hooking up the circuit, right? So I'm going to hook up my input to the input terminal through the R1 resistance. I'm going to, let me put this on the side for a minute. And I'm going to hook up by the way, pin 7 is going to be connected to the positive supply of 12 volts. I'm going to use 12 volts, 12 plus and minus 12 volts. And pin 4 is going to be connected to the negative, okay, of the supply. So I'm going to hook it up just like this to the negative, okay? And of course, I'm going to ground it. And then this one, I'm going to connect 7 to the positive supply. And of course, I'm going to also ground it. and so now I have the device hooked up to the plus minus 12 volts that it needs in order to run, in order to work. If I don't have those supplies connected to the op-amp, then it's not going to work. And finally, I'm going to hook up the the resistance, the feedback resistance, which goes from pin 1. Okay. Sorry, let me just make some room here. Let me move one over here. Let me move this one over here. And then I have space now. So I'm going to hook up the resistor 2 between pin 1 and pin 6, and that's my feedback resistance, okay? And now I have everything I need. I don't need this extra ground. And so now, as you can see, it's the same setup I had before, but like I mentioned, now I have an integrated circuit, an actual integrated circuit hooked up to this circuit. And of course, it's going to do the same thing it did before, right? So I'm going to put a probe at the output here. And of course, we know that this is 12 volts, right? So, and then I'm going to run it. So if I look at this circuit here, I have 12 volts. Let me change this input here, because otherwise it's not going to give me a real a good value. Let me lower it down to maybe 2 volts, the input supply. That's better. And so now I'm going to run it. So when you have this case, right, you have an input power supply of 2 volts. I have an input resistance of 2 kilo ohms and an output resistance of a feedback resistance of 10 kilo ohms, right? Okay, so again, I'm going to hook up the probes here. I'm going to have an output probe here. And of course, I know that the input is 2 volts, right? So the gain is going to be 12 divided by 2. So it's going to be a gain of 5, and it's going to be a negative. So when I run this, as you can see, the output is actually minus 10, right? And of course, you know, if I change this now to maybe if I change it to I don't know, 15, let's change it to a 20 will be too much because I don't need a gain of 2, but let's change it to a 5. So that would be a gain of 2.5, right? If I do that and run it again, you see that the gain is 2.5. So 2 times 2.5 is 5 volts, right? So you see how it works, right? Now, but one of the things that happens is that, for example, you may have in a circuit, you may have a design that includes many of these operational amplifiers, right? For whatever reason, you may want to have different stages, right? You know, of the same circuit giving you different specs. Because for one thing, you can use this op-amp to do different kind of operations, right? So you may have in a circuit, you may have a lot of these op-amps that you need to connect together, right? For different designs. If that's the case, then every time you hook up one of these op-amps, you're going to need to hook up the power supplies. Excuse me, the plus and the minus volts to each one of them. Well, that's kind of tedious, and is that also time consuming, but also it makes your circuit, you know, looks a little crowded, if you will, right? Because you have to have all of those 12 plus and minus 12 supplies in every instance of the op-amp. So one thing that we can do, which is very useful, and let me get rid of this op-amps here so that they're not on the way. One of the things that we can do is use this feature here that is called the connectors. We're going to go to Place, Connectors, and put a one-page connector, and you'll see how that works in a minute. So I'll put this one here, and I'm going to label it V+. You can label it whatever you want, but it's got to make sense to your design, right? And I'm going to hook up another one here, and I'm going to call that, I'll put the connector, and I'm going to call this one V minus. Okay, and what I want to do is, and just so you'll see, I'm going to flip it. Okay, so now I'm going to, for a moment, disconnect my sources, my power supplies. And I'm going to bring this one here. Okay. And I'm going to disconnect this one also. And I'm going to hook it up to this end right here. So what I did, as you notice, right, I just brought the power supplies to these connectors, right? One will be the positive, one will be the negative, right? And let me expand that a little more. That's better. Of course, I need a ground, so I'm going to hook them up together like this. And I'm going to connect both to the ground because that's the ground common to both. So what you notice here is that, of course, this is a positive supply, right? 12 volts, and this will be a negative supply if I hooked it up to this point, right? And so when I I'm going to use this now as a generic connectors, and I'm going to hook them up to 7 and 4 as needed, right? 7 will be the positive. I'm sorry, 7 will be the negative, and 4 will be the other one, right? And so when I do that, then if I hook them up, and I'm going to get rid of this here, I don't need it anymore, right? So as you notice in in one of the pictures I showed you, and this is one of the ones I show you in the PowerPoint. Let me bring it up. See how this one, 4 is connected to the negative, and 7 is connected to the positive, right? And that's what the integrated circuit will have to be connected to. See, this is one of the typical ones you will see, and it shows you the different pins, right? As we already saw, I'm connecting 2, which is the inverting terminal, 3 is the positive terminal, 4 is the negative power, 7 is the positive power, and we're not using this 2, and not even this one here, okay? We're gonna leave those by themselves alone. So let me go back, and so 4 is gonna be the negative power, so we'll see, right? So I'm going to then go back to place, and I'm gonna say connectors, home page connectors, and I'm gonna create a connector, right, that I'm gonna connect to this pin 4, and I'm gonna select the negative supply, okay? I'm gonna repeat the same thing, and I'm gonna say place connector, open, and I'm going to hook it up to 7, and 7 is going to be the positive supply that I have. So what that means is that I'm basically, and let me move it so we can see this a little better. Okay. All right, that's better now. So what you can see now is that I have really created this connections here that are tied to this power supplies, right? And what that means is that if I have to insert another op-amp anywhere in the circuit, I can use the same connections, okay? I can simply do the same thing, okay? So if I go, 4 is negative, right? So all I have to do is say connectors, home page connector. I'm gonna hook this up to the negative supply, and I'm going to do the same thing for 7. Let's say place connectors, on page connector, and I'm going to hook this up to, I'm going to select positive supply. So just like you can see here, every time I make these connections, it's hooking up to either the positive or the negative. And I can repeat the same process without having to do this whole connection again for the 2 power supplies. Very useful, right? So let me go back for a minute here. All right, so you see the use of it, right? everything's more, cleaner. And again, you can reuse this later for other circuits. So let me get rid of this because I'm not using this other power, op-amp. As you can see now, I get the same result, right? Because if everything is okay, then it means that I actually am connected to the negative here and to the positive here. And if you want to double check, you can bring probes and check it. By the way, this is another nice feature in another tool that you have that is nice to know that you have, because you can use the probes live. So right now, see, I'm running the circuit, I'm running the simulation, and I can select the probes, right? I can bring the probes here, for instance. And again, you have to make it to a yellow, right? If it turns yellow, then it means you're okay. And I'm going to bring the other one here to the positive, and it turns yellow. As you can see, I have minus 12 volts tied to pin 4 and plus 12 volts tied to pin 7, right? So I hope you can see this. This is really a nice feature, right? I'm going to get rid of those probes, but one thing I wanted to point out is that while I'm running the simulation, I can put probes anywhere I want. All right, I'm going to put another probe here just to show you. Right, and you can see that I can do that even though I'm running the simulation. As you notice here, the instruments on the right-hand side, I hope you can see the instruments here are all disabled. I cannot use any of the instruments while I'm running the simulation live. They're all disabled. If I stop the simulation, obviously, then the instruments are enabled again, and I can bring them into the circuit if I needed to. Okay, but if I'm running the simulation again, I'm not able to do that. So so that's another great advantage of using probes. Okay, just to mention that. All right, so let's get rid of those probes. And this time, I'm going to replace this resistance by a capacitor. And if you remember the previous slide, we said that in the previous PowerPoint, we said that if we replace the capacitor here by, this feedback resistance by a capacitor, the circuit becomes an integrator, okay? Again, we don't have to do the analysis. It's just so you know how to use these features. So if I replace this, I'm going to double click on it, and sorry, I'm going to right click on it, and I'm going to select replace component, and then I'm going to select the capacitor, and I'm going to select this 1 microfarad. Then I'm going to change it. Actually, I'm going to change it to a 0.1 microfarad, 0.1 microfarad, so I can see a little more of the signal at the output. I click OK. I think we'll be okay with this 2K. Well, let me just bring it back to 1K. All right. So as we said before, if what this circuit will do is it will integrate the signal. It will integrate the input signal. So to do that, let me change this, or instead of using a battery, I'm going to use the function generator. I'm going to bring the function generator that we used before, so you remember, and I'm going to hook up my input function generator to the input, right? And I'm going to select, I'm going to turn it on, and I'm going to select sine wave, which is already a sine wave, and I'm going to increase this to, I'm going to make it a peak-to-peak signal, and I'm going to make it a 2 peak-to-peak. So I'm going to increase that to 2, and I'm going to keep moving towards the right, and I'm going to bring that 2 to 0, right? So now I have a 2-volt peak-to-peak signal coming out of the function generator, and I'm going to select the frequency. 1K is okay, so I'm going to leave it as 1K. So I have a input signal with an amplitude of 1 volt, it's 2 volts peak to peak, and with a frequency of 1 kilohertz. And it's a sine wave, so then I'm going to look what happens to my output when I run that circuit. So to do that, I'm going to select my scope again, and I'm going to hook up my my input to the function generator, or my channel 1 to the input function generator, and channel 2 to my output, right? And I'm going to turn my scope on and then see what happens, right? Now let this set aside so you can see it more room here. Okay. And when I run this, as you can see, oh, I get an error. That happens sometimes. Let me stop that for a minute. Okay, so you saw just a minute ago that I get an error while simulating this. And I'm kind of glad that happened because although it's very unusual that you get that error, you might get it every now and then. So it's a good thing that you saw it, and I'm going to show you what the error says. Simulation error occur. Would you like to run the convergence assistance to attempt to resolve the problem automatically? And what it does is Multisim itself tries to fix it. And so if you say yes, right, and which I did, it's going to correct it or try to correct it. Now it may take a little while, right? Like right now it took like 10 minutes to run through diagnostics, and hopefully it fixed it. But we'll see. But in any case, I don't think you're gonna see this very often, but it may happen every now and then. So it's a good thing that you see it here. And in many cases, all you gotta do is just to say solve it automatically, wait for the program to run its diagnostics, and then hopefully it's gonna solve it. So let's see now. Let me just make sure that we have this correctly. Okay, and all right, let me open up the scope and run it. And let's see, probably need something larger here. Let me just see for a minute. Okay, so when I run this, as you can see, it looks like it solved the problem. So now what I do to look at the information again, I need to, set this up so I can see more detail on the screen. One of the things you can do sometimes when you use this auto set button here, it'll try to set up things for you so you can see them, at least find the signals that you can see here, right? So from here, I can then just again select the volts and the timing to look at a little more detail, and that's what I'm doing right here. Okay, all right. And I'm going to select the timing. Then you can see now they're both signals, right? So if I want to move it up and down, I can do this, see the position, and I'll do the same thing with this one. And now you can see that the input is in yellow and the output is in blue, and is integrating the signals. So the integral that you see is the integral of the sine wave, you get a cosine wave, right? Kind of makes sense. If I do it for a